Okay, we're gonna get started. Um, Welcome to the Othello help session. This. Okay, so a quick reminder, please fill out the final project declaration form by tonight at midnight. If you haven't already, this form is binding. And after the deadline, you will have to email the HTAs to switch your final project, and permission will only be granted for extenuating circumstances. So as a quick overview, we're going to first go over how to play Othello, then writing the GUI, switching turns and the referee class, checking for valid moves and flipping pieces, working with copy constructors, and project design. I low-key don't think this is in the slides.
Yeah. We could, I could talk very briefly about how to play Othello. It's really simple. Don't let people tell you that Othello is like a complicated game. It's not. Basically, how it works is that one player plays as white and one player plays as black. They take turns placing pieces on a board, and essentially their goal is to sandwich the opposite color with two pieces of their color. And then when they sandwich the opposite color, so like if I put down a black piece and then they put down a white piece and then I put down a black piece on the other side of their white piece, I can flip all the pieces in between the two pieces that are my color that are theirs to be my color. So the white piece that I sandwiched, I would flip it to be a black piece. Um, it's helpful to have a visual for that. So you can honestly look at the demo,
Yeah,
or just like look up a YouTube video of like people playing Othello or explaining Othello. I promise
not,
it will make a lot of
yeah.
sense within like 5 minutes.
It's super simple, and the goal of the game is just to get the most pieces on the
Yeah,
board of your
exactly.
color. Um, and it's fun.
It is fun. I feel like this is a fun final project too, because once you get the game working, as you're like debugging and everything, you can just play Othello. And who doesn't love that? Like
You don't need another
Lindy and I were
person.
playing Othello for an hour and hours
Real.
yesterday. All right, so let's talk about writing the GUI or the GUI. If you don't know what that is, it stands for Graphical User Interface, and it's just like a fancy word for what you'll like interact with um, in terms of the game. So it has two components for Othello. There's the actual board, which is an 8x8 board, and it also has a border. So maybe that kind of reminds you of Tetris a little bit, hopefully not in a bad way. And then on the right of the board, there's like a little control dashboard that configures the game's settings. And I'll talk more about that, but we actually kind of wrote the control for you already. So you don't have to worry too much about making the control part. That's like pretty much set up. There's just a few things you have to add. So the first question you should be asking yourself is how are you going to represent the board and how are you going to store the pieces within your board representation? And then the other thing that you should ask is what components should know how to react to user clicks. So an important part of Othello will be taking those user clicks and like translating them to placing a piece. But that's not that hard. You'll see we have some good guidance on that in the handout. Okay, so here's the board. You can see here's a little animated GIF of people playing Othello, and maybe it's a helpful visual for what I was explaining earlier about like how the game works. You could implement it with two 2D arrays, one for the pieces and one for the squares. Or you could do one 2D array of smart squares that essentially have a functionality where they can contain a piece. So they can either be empty or contain a piece, and they know like what piece they contain. That's the approach we recommend. It's honestly probably easier than doing the two 2D arrays, but if the two 2D arrays is like really calling to you, you can go for that too. Um, so question, we're always talking about graphical versus logical. So when will the board need to graphically and logically change? Well, the answer is when a player clicks or adds a piece, or when the pieces get sandwiched by the opposite color. And that means all the pieces that are in between those two colors need to flip to be the opposite of whatever they are. And then part of full functionality is highlighting which moves are allowed. when it's a human player. So that's like mainly a graphical change. Um, and that happens when it's the human player's turn. You need to figure out which moves are allowed. Basically, you're only allowed to make a move that would sandwich an enemy piece. So the first thing you want to figure out is which moves will sandwich an enemy piece, and then you can highlight those as valid moves for the human player. When does the board not need to change graphically? Basically anything with the mini max, like the human player shouldn't see what's going on with the mini max because the mini max is like essentially the computer playing its own little game of Othello, like in its mind, you could think of it. And the computer player should only see the result. It shouldn't see like all the possibilities that the computer is thinking through. It should only see the decision it makes at the end. So how we're going to do that is we're going to make copies of the board that are only logical, not graphical. And the computer is basically going to play on these logical boards and not on the like actual graphical board that the human can see. And we'll talk more about implementing that, but it's a really cool part of Othello. And finally, we have the controls. As I mentioned earlier, we pretty much set these up for you and like wrote the code for the controls for you. You'll just have to add a couple things to the controls class to sort of integrate the class with the code that you write. So you're going to associate the class with your top level logic class, which will be probably called game, and you can use it to configure game settings. Um, and using like the things you need to fill out in the controls class are related to the game that you're going to write, the game class. So you need to figure out when you're going to reset the game, how you're going to set the game player settings, like maybe using methods from your game class, and you're gonna have to add a score and a game over label to the pane. In the controls class, there's pretty good, like, those green to do comments for where you should add your code and what you should add. And this is definitely something you can come to ours to ask us about if you're confused about anything in the controls class, because you didn't write it. So maybe something's new to you and we can explain it.
Okay, next up, we're going to go over switching turns and the referee. So, the game would be pretty boring if it only had one player, and so we want some way of figuring out when one player's turn is over to switch to the next player. And the way to do this is we can delegate it to a referee class. So the idea behind the referee class is that you would keep a reference to both players, so the white player and the black player, and you keep track of which one is the current player. And when it's the current player's turn to move, you'll tell it to move, and this would be pretty similar to how you did CS15 controller from Tic-Tac-Toe, except this time you will be writing the class yourself because I think controller was support code or simple
Yeah, it
code
was.
that was given to you. Um, Referee should handle checking for illegal moves as well, so it keeps players from moving out of turn. If it's not their turn, they shouldn't be able to update the board at all. It keeps players from moving when the game has ended, and it should make sure that a human doesn't try to move during computer player's turn. So if it's human versus computer, if it's the computer player's turn, the human shouldn't be able to update the board either, and vice versa. So it should just generally be checking if anything like of the game logic is being violated or not. And also, referees should contain a timeline. But why, you may ask, is because computer players' moves should update on screen, which with each timer tick. I think one of the like functionality requirements that we require is that it's like not the AI won't complete the game like in like 1 second, and it'll each move will be spaced out so that you can see each move. And so how do we do that? The first thing that you should do after your timeline calls the keyframes methods should be to call stop on the timeline. And a question to you all is where then should we be calling play? And then should the referee tell itself that the player has finished moving, or should the referee be told that a move, either a human player's or a computer player's, has ended? These are great questions. And I will say that the referee should be smart enough to be able to do this for both human players and computer players. So a human player, you might not necessarily think of as needing a timeline, but you don't want to have two separate methods that the referee is keeping track of human players and computer players. You'd rather just have a good generic method that is able to do both at once.
All right, let's talk about move, validity, and flipping. So this is sort of a, a little algorithm that you'll write. The sort of main algorithm of this project is the minimax AI, of course, but the valid moves is also, I think it's a really cool one. Like it's just interesting. And it uses recursion, or it should use recursion in a cool way. So basically we want to check for valid moves. Um, the first like condition for a move to be valid is that there's no piece there already. Seems pretty obvious. And then the second one, which is a little bit more challenging one, is that we need to make sure that that move would create a sandwich um, of like the opposite colors piece by placing it. So how can you check if it will create a sandwich? So you could either do this with recursion or iteration. We strongly recommend recursion. It's maybe conceptually a little bit more challenging initially, but it actually like makes for much simpler code, and we'll give you pseudocode for how to do it using recursion. And obviously you can always come to ours too to ask about that pseudocode. So we're gonna start with a square, and we're gonna check to see if the adjacent square is of the opposite color. So if it is of the opposite color, it means we have like the potential for a sandwich, right? And then we're going to keep going like in one direction, the direction that we found the opposite color square. And we're going to check the next square and the next square and the next square until one of two cases. Either we reach a square with a piece of our own color, which basically means like I started a piece of my color, I saw a bunch of like enemy pieces, and then I saw one of my pieces again. So basically, that means the move is valid. Or we reach the edge of the board, which means, or like a totally empty square, um, that the move is invalid, essentially. So we have to check all adjacent squares and by extension, all 8 directions that can like stem out from any individual spot on the board. And if a sandwich is found in at least one of those directions, the move is valid and a piece can be placed at that position on of the board. So like wherever we want to place our piece, the like we're gonna sort of look from that spot in 8 directions, and like all we're looking for is that it can make a sandwich in one of those directions, and then it's valid. So how can we do that in a code minimizing way? You don't want 8 different methods for the 8 different directions, so there's definitely a way that you can factor out a lot of the code into a helper method and then call that helper method 8 times and tell it, go up, go left, go right, go diagonal, something like that. Um, so next for checking valid moves, here is the pseudocode that will check for sandwiches recursively. So I'll just sort of walk through it a little bit. Basically, we have it return a Boolean, and this Boolean is going to be, if there's a valid move, essentially, or if that is a valid move. And it takes in row, column, so that's like the square that we're checking, the row direction, the column direction, so that's which direction we want to go. The player color in this Boolean scene opponent. You'll see where that comes in. So the first thing we do is we check if right away, if the square that we're at is empty or out of bounds. That means definitely not a valid move. Um, if the square that we're at has one of the opponent's pieces, then we are going to recursively call this method, and we're going to essentially like say we're going to the right, we're going to add one to the column each time. Or if we're going up, we'll add one to the row each time. Um, and then you see we keep the row direction, and then we return true for seen opponent. So now we've seen an opponent, so that means there's a lot of potential for this to be a valid move. All that needs to happen is that we see one of our pieces. So that's this third condition. So now if the piece we're at is one of our pieces, and we've seen an opponent, that means we can make a sandwich. So that's the true condition. And then if none of these conditions are met, like if we never find true, we just default to returning false. Okay, we could also do this iteratively. There's a lot of parallels in general between while loops and recursion. So you could loop through the 8 different directions and keep while loops um, going that keep track of whether a sandwich has been made. Um, if you want to implement it this way, you can, but it is like honestly a bit more complicated and you don't have the pseudocode. So recommend going with the recursion, but it could be a challenge if you want to think about it. All right, so next, we've checked that a move is valid and we played our valid move, but now we need to update the board to reflect that we just sandwiched some pieces. So we're gonna do a very similar process to when we were checking for valid moves. We're gonna check in each direction to see like which pieces exactly have been sandwiched. And then in the direction that has a sandwich, we're gonna flip the pieces like kind of as we go through in the middle of the sandwich until we reach a piece of our own color again, basically completing the sandwich. Again, this can be done either recursively or iteratively, and it's a very similar algorithm to checking for a sandwich. And if you use recursion, one of the big benefits is that you can actually combine these two functionalities into just one method, where essentially like you check for the valid move, and then once you like place it down, you like basically call the same method, but now you're in flip mode. And as it's going through in the directions that there is a sandwich, it's flipping all the pieces. Um, what about when you get to the edge of the board? You shouldn't get to the edge when you're flipping because there's always going to be like a piece of your color on the other side of a sandwich. So you got to remember that a sandwich could be created in more than one direction, and you have to flip them in all directions that have a sandwich. And as far as the edge thing goes, just be careful with that. And after your flipping works, you're pretty much done with like the human player aspect of Othello. So,
Yes. Okay, moving on to copy constructors. So as a background, let's go over method overloading. So in method overloading is when in Java we can use a design pattern where we create multiple methods of the same name, only if they take different argument lists. And this allows us to write methods that have a similar end goal, but can achieve different things depending on the inputs. So for example, say I want to create a sum method and I want to be able to add in the cases where my inputs are 1 2-ints, 2 3-ints, and 3 2 doubles. So these different sets of arguments are very different, but the goal of the sum method would be the same for all three of these methods. And so how to achieve this is in Java, we would literally write three separate methods that have the same name. So each of them start off with public int sum, public int sum, public int sum, but they all have different arguments. And this is totally legal in Java. The compiler will just call whichever method matches the arguments at compile time. Um, but yeah, this is just a super efficient way to have a method that has different arguments that you want to do the same thing. Okay. So you've already done this actually. Java affects when you create a rectangle, this uses method overloading. So for example, in your lab or in your cartoon, you chose which of the rectangle classes you wanted to instantiate, depending on which arguments you were giving it. And so how this relates to copy constructors is you can do the same thing for a constructor. So how can we test out possible moves in our minimax while maintaining our main game board? And the answer is to use a copy constructor. And the benefits of using a copy constructor are that it lets you replicate the current state of the game by producing a distinct instance that is logically identical to the visual game board. And as a note, this is in addition to your logical representation of the board we see visually. Um, so you should have a separate, I guess, object that keeps track of a copied board if you're playing hypothetical moves on the copy board. And since higher intelligence requires looking at 2 or 3 moves in the future, we must pass the copy boards on which we made previous moves to successive levels of recursion. So similar to method overloading, a copy constructor will create an overloaded constructor for the class. And literally in your code, your board class will have two constructors. And one constructor should take in exactly one parameter, um, which will be a reference to some instance of the same class. So in this example, it's public car, car Toyota. And this is, I guess, what a copy constructor's constructor like might look like. And the copy constructor will then use accessors to retrieve important information from the instance and then assign the exact same values to itself. So as a note, you should never copy objects from one class to another, only primitive types like ints or booleans. And I guess if you're copying objects from your original object to the copy object, then if you're updating that same object in the copy constructor, you would be updating the original object. I know that was like, I worded that horribly, but the point is if you're playing moves on a copy board, and you're sharing objects between the copy board and the real board, then you would actually be updating the real board as well. So you just want to make sure that you are creating new objects that don't reference the old objects when you do a copy constructor. And here's an example of that. So this is a public class flower. Um, there's a normal constructor up here. We're not showing you the whole code, but just think of it as like your, I don't know, a common constructor that you've already made. And then here is the new copy constructor design. So we're taking in an object flower called flow. Then we're setting all the attributes in our copy constructor class to be the same as the original flower object. So you can see here we're setting the instance variables height and type to the original flower's height and flower type. Um, but then for the actual petals in the flower, rather than just setting the the petal array to be the same as the old petals, we have to create new petals so that there are new objects in the petal array that don't reference the old petal array. And how we're doing that is we're looping through all of the old flowers petals, and then we all we need to know for the petal is what the original color was of the original petal. And so when we create the new petal array in this copy constructor, we are populating it with new petal objects, but using the old petals color. So it's essentially logically the same, just like this is making sure that it's a copy and not the original. So yeah, this example would make an identical copy flower, whatever flower it's passed in. Note that for the array of petal objects, we do not directly copy them like this. Petal array equals flow dot get petals. And remember, since objects are passed by reference, the above line would make the copied array point to the exact same petal, which we want to avoid. And also, as a hint, a board is just a 2D array of objects. So all we need to do is iterate through each location in input array and make a copy of its contents for each corresponding location in the new array. And so program design. Since Othello is a large project, there are many different designs that can work. However, just make sure that you abide by object-oriented programming standards. This is kind of like your culmination of your CS15 design skills. So yeah, just show up everything you know. But although there are many designs that will function, some are more efficient and easier to implement than others, and also will make expanding your code easier once you get further into the project. Um, so since there's a lot of code, you just want to make sure it's as well organized as possible because otherwise it'll just set you up for crazier bugs later on. We'll go over some classes you should consider using. And as a note, this is the design that we recommend using. If you feel strongly about changing this design, go for it. But our recommended design is set up for a clean OOP design. And as always, justify all design choices in the README. Um, so here are some potential classes you might consider creating. There's a setup game class, which would handle this game setup logic. And this is an empty class that we provided for you in the stencil. In past projects, game has been the top level logic class. but you'll find a lot of logic going into the board class, and this is expected for Othello. Um, then a referee class, which we went over, and Othello square class, which could represent a space on the board, which is either empty, black piece, or white piece. A piece class, consider if you need two classes for black versus white pieces, or you could also create one class for them both. Um, a move class, which would be used to track the row, column, and score of a move, and a board class, which would handle a lot of the board updating logic as well as copy constructors. Um, and we never do this, but we're giving you this class interface diagram. Please look over this, use this, try to understand this. You can also come to ours and talk to us about this at a high level, I guess. You can see here there's a player interface that human player and computer player implement from. Um, but yeah, feel free to use this as much as you want.
Yeah, so now let's talk about some of the like most important design questions for Hello. Some of these we kind of like basically answer for you, but some of them you should think about. So, what is the move class? We kind of talked about it before. It stores information about a potential move, but maybe you want to think about like why that would be helpful. Do we need a board class?
Wait.
Yeah. Yeah, you do.
I think so.
Where should the 2D arrays go? Is another good question. Do we need a referee class? Also, yes. You can sort of it might be another good thing to think about, like why the referee class is helpful. We kind of discussed it earlier, but like why we can't have the players keep track themselves of like whose turn it is. And then talking about this Othello square method, which is kind of a classic, or not method, class, which is kind of a classic wrapper class that we've seen before. And think about some of the methods that could go in this wrapper class to avoid having so many like instance variables or conversions in the board. So we could add get row, we could add get column to the Othello square, and that helps to convert from Y and X to row and column, kind of like you may have done in Tetris. The Othello square also might have methods like add piece or flip piece, and that's kind of what we talked about with having like a smart square class that knows how to do more than just the Java effects rectangle. Yeah, so another good question is where and when should players be able to click? And where should the click logic that handles, that sort of action event go? And then some polymorphism considerations. Basically, we already mentioned that it's a good idea to make an interface for the human and computer players. So think about what they have in common with each other and how you could implement things so that the rest of your program like doesn't really care about whether it's a human player or a computer player. It can call the same methods on either type of player, and the human or computer player will deal with those methods maybe in a different way, but the other classes don't have to know if it's human or computer. Now like let's talk a little bit about association. So what is the association between the setup game and the controls class? I actually believe on the class diagram we gave you, the setup game class is just called the game class. Those are the
Mm.
same things. So luckily we gave you a class diagram. So this is more about like looking at what we gave you and understanding it. I mean, it's not necessary that yours is exactly the same, but it should give you a clue about when association is sort of necessary and when it can be avoided. And then think about the referee and the players. Like, do the players need to know about each other? Um, and how can we utilize parameter passing and setter methods to set up two-way association? I think we kind of talked about that. It's like component container association. And then the other question is how do the different board implementations impact association? So that has to do with the copy constructor. or sort of how you choose to represent your board as well. So like you want to think about when you're making a copy of the board, what's the best way to like get all the information from one board to another. And the final note that Mario has is to minimize association as much as possible. Yeah. So if you find that, association is really just a sort of fancy word for a class storing another class as an instance variable. So if you find that the class is like only using it in one place, or maybe there's a way to do it without the two classes like knowing all that info about each other, then you should try and get rid of those instance variables and instead like pass the class in as a parameter to a method, pass information to the method, or like refactor your method so that like the information that is related to one class is kept in that class and the methods that are related that use that information are not in a class different from the information that they use, if that makes sense. Okay, so the final note, good luck with Othello. Start
Yes.
right now, today. Just take a look at things, no pressure, but this was already a great step coming to these help session. Like, hopefully it got you thinking. It takes time, but it's not too scary, and we are here to help you. So if you have any questions, definitely come to ours. First step is human versus human, and that should like be a top priority for you because it is going to take you some time to figure out the computer player and the Minimax algorithm. So you really want to make sure you get human versus human working as soon as you can, so you leave yourself a good amount of time. Do you want to talk about the next one?
Yeah. So don't underestimate Minimax. It is a challenging algorithm to grasp conceptually and takes time to debug. But also, we will have another help session after Thanksgiving just for Minimax. And we similarly give you a lot of the pseudocode, so don't be too intimidated by it. Just I guess start thinking about it. But yeah, feel free to hand simulate, use print lines, and think critically about your problems. And as a tip, write a method for debugging that prints the current board state. Oh, this is kind of what you were saying you did when you
Yeah, a lot of different methods in my mini max, but it really helps me. Yeah.
Yeah, but start now and good luck. Othello is a little challenging, but in our opinion, it's the most gratifying final project to do, and you got this.
Yeah.
It'll happen, and it'll be so awesome.
It's such a cool feeling playing a AI that you created at like a board
Crazy
game.
flex.
Yeah, it's
Yeah.
really fun.
Okay, so now we can open it up to questions if there are any. Um, yeah. Do you guys have any questions?
You can put them in like the
Yeah.
chat or speak up.
Yeah, I had a question. Can you sandwich like a piece when you're on like the board is on the left, but your piece is on the right?
The board
Um,
is on the left, but your piece is on the right.
like can the board be like the left side of a sandwich in a way?
No.
No,
So it
no.
Okay.
has to be like in between two of your color
Okay,
pieces.
it has to be two colors. Okay,
Yeah, good question.
thanks.
I wonder if we can.
Yeah, like you could
Okay.
do the one you made, but okay.
I'm scared it wouldn't like run. I never, yeah. Okay, I can also share my screen right now and we can go over this too. But basically, it's black player's turn right now. And so the black player's valid moves are these four highlighted squares. And so, for example, I could just put my piece here. And since there's a sandwich between the piece that I put down and the current piece on the board, which is black, I turn this white square to black. And so now I gained a point. And I guess there's a computer player.
Yeah.
So it just made its move as well, which it decided to put its piece here. And so now it's my turn again. And these are my valid moves, these five squares. if I were to put a piece down here,
Mhm.
there's actually two sandwiches here because there's a black piece here and there's a black piece here. And so it would flip both this white piece and this white piece since I'm sandwiching both these white pieces.
Yeah.
So
It's
this,
like one is on the diagonal and one's on the vertical.
yes,
I feel
like
like it's
that.
kind of like a word search almost that everyone has
Yeah,
to have.
good point.
Yeah, so basically you can just keep going, making these valid moves, see the computer player is gonna go. And like I actually don't know how good this computer is, but I mean, once you'll kind of learn, like this was a bad move by the computer because you want to get like your piece into the corners. That's like really powerful in Othello. Um, but yeah, if anyone has any more questions about
Yes.
how to play the game, but hopefully that gives you more of an idea of how the sandwiches work. Um, Once again, like yeah, definitely just look up an online version, play around with it, look up a YouTube video. It really is not too complicated, and it's fun.
Yes. Any other questions?
All right.
Okay. Well, thank you guys for
Yeah.
coming.
If you haven't already thought